Okay. Good morning. Can everyone hear me? I am so glad they turned on the lights. I was like, I will not be able to see anyone's face. I won't be able to tell if they love it or if they hate it. So, good morning. I'm glad to see you all. By show of hands, how many of you have had an opportunity to play around with machine learning? Nice. How many of you actually get to use it in your day-to-day jobs? All right, I'm totally jealous, a lot of you. So we're going to go through a few scenarios, and I want you to think to yourself, is this ethical or not? A man is not granted parole because a machine learning model says he will be a repeat offender. Is that ethical? A woman's life is saved because a machine learning model found breast cancer that was undetectable by a doctor. More than 1/3 of A-level results in the UK downgraded to maybe a B or a C or an F by a machine learning model. Women aren't recruited by Amazon because a model has incorrectly learned that women don't make great engineers. As machine learning moves from the research lab to the enterprise, questions around ethics become even more critical. And by the way, all of these examples that I shared with you are real. After our time together today, you'll learn how to incorporate risk and ethics in your machine learning development. Hello, everyone. I am Kesha Williams. I am from, if you can't tell by my accent, I'm from the United States. I have been in tech for 28 years now. And I don't know where the time went, but I always jokingly say, I'm tired. I am ready to retire, buy my house in Jamaica. But as I share about my journey in tech, I always like to use programming languages. So I started a very long time ago with the BASIC programming language. Has anyone ever coded BASIC? All right, you're my people. I was in high school. My father bought a personal computer. He put it in my playroom. So literally in one hand, I had a Barbie doll and I had a BASIC manual playing on a new toy called the computer. I went to college. I majored in computer science. My first job out of college, I was a web application developer using active server pages, ActiveX controls. Anyone remember ActiveX controls? And VB script. I remember the day the Java programming language was released. And I researched that language and I said to myself, wow, this is amazing. This language is going to take over the world. This is where I need to take my career. And so I left the organization where I was working so that I could become a Java web developer. And that was probably the best career choice I've ever made. Java has given me a very solid foundation. And I always jokingly say, if the wheels fall off and there's nothing left, I can always go back and be a Java developer. Then I was introduced to the cloud and AWS, Amazon Web Services. And the excitement that I felt for Java, I then felt for AWS and the cloud. And then because of my exposure to the cloud and all of the AI and ML services on AWS, I transitioned to AI and machine learning. And so I think about my journey really from Java to the cloud to machine learning. And now I'm trying to figure out what's next for me. I haven't quite figured it out yet, but hopefully I'll retire before I need to figure that out. I currently work for a company called Slalom. We are a global consulting firm. We help organizations build better software and we help them move to the cloud. We have an AWS practice, GCP, and Azure. I currently serve as the program director for our AWS Cloud Residency program, which is a career accelerator for cloud engineers. So we work with students straight out of college or career changers that have gone through a boot camp, and we upskill them on AWS. I'm very active in the community, traveling around the world, speaking, and because of that, AWS has given me a few recognitions. I'm a machine learning hero and an ambassador, and I still try to keep my coding skills sharp, and I'm also an Alexa champion. So most of you in here, by the poll that I took early on, you're very familiar with AI and machine learning. And so simply put, machine learning is a subset of artificial intelligence where you apply mathematics to large data sets to find trends and patterns that help you make your business decisions. Now, machine learning is widespread. It's a very hot topic. Everyone is talking about AI. Everyone is talking about ChatGPT. Generative AI has really taken the world by storm. When I began my machine learning journey about 7, 8 years ago, and I started researching where machine learning was applied, I was just surprised to learn that it already touched my life in so many ways. So who in here has Netflix or a similar system where you watch movies? Well, Netflix uses machine learning to make those movie recommendations. Amazon also uses it to make product recommendations. I was surprised to learn that at least in the United States, courthouses, judges in courthouses use machine learning to determine if someone is going to be a repeat offender. And if the machine learning says yes, that person may not get parole. And that's caused a lot of uproar. Banking, in the banking industry, they use it to determine if you're going to default on that home loan, that car loan, and you may not get it. Audience segmentation. Department stores, fast food chains like Starbucks use it to better understand their customers so they can make marketed campaigns. And anomaly detection, which is one that I really appreciate sometimes. It looks for credit card fraud and suspicious activity. And then personalization can learn your customer behavior and tailor your experience for you. Facial recognition. Delta Airlines actually took a picture of my face in order for me to board my international flight here. And of course, chatbots. When you reach out to online customer service systems, I was actually online with Delta this morning. My first point of contact was a chatbot. So how do machine learning systems work? Well, the machine studies data. It finds trends and patterns between inputs and outputs. And essentially, it learns how to map those inputs to a specific output. The mappings are stored in a mathematical model, just called the model for short. And the model, once you have it, you send it information or data that it's never seen before. So it takes that new input and it gives you a prediction or an output. So will this person be a repeat offender? What should this person's final grade be? And what is this an image of? Those are types of questions that machine learning can answer. When I started peeling back the layers on machine learning as a Java engineer, I realized that in traditional software development, we write the code to tell the machine what to do, and the software spits out the data. And so we use languages like Java, which is, of course, my favorite programming language, C#, JavaScript, Python, and the list goes on. But machine learning differs from traditional software development because we give the machine the data, and it essentially writes its own code trying to solve the problem we're trying to solve. So it's the complete opposite, and it's very cool. The process to develop a machine learning system is pretty standard when you're using what's called unsupervised learning. So you have your training data. For example, if you want to train a model to predict the cost of homes in California, you'll use factors that influence the cost of the home, like the location, age, etc. And you have your training data that has those factors and what you're trying to predict, the cost of a home. And you feed that data to a machine learning algorithm in the training process. And that training process produces this learned function. That's what we're calling the model. And then you send in your input, the factors that could influence the cost of a home. And the model magically spits out what that home may sell for. And that's called the prediction. And so when we have this prediction, there are several questions about the output. Can I trust this number? How can I find errors? Why is the cost of the home so expensive and it only has one bedroom? So ethics and risk questions happen across the machine learning lifecycle. And there is the need for ethical AI because the data that we use could be biased. So of course, I had to play around with ChatGPT, and I just had fun asking it, what is ethical AI? Now, I'm asking AI about AI. That could be considered a conflict of interest. But I found the definition pretty spot on. I saw terms like fairness, transparency, responsibility, human rights, don't perpetuate bias, consider the potential consequences, mitigate any negative impacts, and overall, it's just a great description of ethical AI. For me, when I think about ethical AI, it really just boils down to one question. I can build it, but should I? And if I do, what guardrails are in place to protect the people that are the subject of the AI? So that is at the heart of ethics in AI. And I can be honest with you, it is very time-consuming, costly, and hard to build a model that you actually trust with the lives of people, at least for me. I want to make sure that those predictions are accurate and fair. So I've been involved in machine learning for some time now. I told you all I made that transition from Java to machine learning, and I've developed several fun use cases when it comes to machine learning. I've developed models that predict the crime in the UK, and coming from the United States, I feel now I am an expert at the crime in the UK. I know when to visit, and I know when not to visit, and I know the areas to avoid. I've developed models and deployed them on edge devices like a camera to alert me when my daughter comes home from school. She's 16 years old, and it tells me whether or not she's happy or if she's sad. And if she's sad, I'll stop by her favorite restaurant and bring her her strawberry milkshake to cheer her up. Now, she did start to understand what was happening, and she started gaming the system, so I had to shut that one down, but it was fun. I've also developed a model and deployed it on a camera that alerts me whenever my kids steal soda out of the refrigerator. So I have 3 kids. They love to snack, and they love soda. So I call it my soda theft detection system. I've also developed models to make course recommendations on the A Cloud Guru platform. That's where I worked before I worked for Slalom. And in the early days of COVID, I developed a model that would predict COVID outcomes. So would the person live or die. I'm glad COVID is gone. But again, just because I can build it, should I? And am I the right person to build it? And are my biases as a human passed on to the systems I'm developing? So I mentioned the word bias. Bias, again, is a pretty hot topic when we talk about machine learning, and it can be a huge problem because it goes against a code of ethics. A machine learning system is biased if it favors or disfavors a certain group of people. So when we think about machine learning systems and the predictions that they make, they can identify a person, similar to what Delta Airlines did for me before boarding my flight. They can predict demographic attributes about a person's preferences, like a course or a movie. It can even predict someone's likely future behavior. And that's the kicker. A machine learning system that predicts your next move, and your options could be limited based on what the machine says you'll do next. But again, you want those recommendations for people to be fair. So how does bias surface in a machine learning system? People often think bias is all about the data, but that's not the case. Bias can be found, of course, in your training data. Let's say we have a data set of homes and we're trying to predict the cost of a home, but in our data set, we only have homes that cost over 500,000 US dollars. That would be considered a biased data set because there are a lot of homes that cost less than that in the United States. And so that data set does not accurately reflect the environment that the model will be deployed in. Bias can also be introduced by the machine learning algorithm itself. And even with a well-balanced training data set, the outcomes might not favor certain subsets of data. And then bias can show up in your model. Once it's deployed to production, models, when you start the retraining process, they have a tendency to drift. And that just essentially means the relationship between the target that you're trying to predict and the features or attributes has changed over time. Have you guys heard about facial recognition technology being banned in the United States in certain cities? Well, San Francisco in California was the first city in the US in 2019 to ban the use of facial recognition. And they banned it because it was biased against people of color. And I thought to myself, as a technologist, like, the technology is not the problem. And so I was slightly offended and upset that, hey, now they're shutting down this technology that has the possibility to do good in the world. And so the technology is not the problem. It's how we as humans have implemented the system. And more specifically, in this case, the data sets that were used to train the facial recognition system. So remember, the technology is not the problem. The humans are. So let's just look at a very simple example of bias that's caused by data. So let's say we are trying to train a model on how to identify flowers, so an image classification system. Does anyone see how this data set could produce a bias model? So let's think about this. If that's our training data and we've produced a model, let's say we're passing in now an image of a sunflower. I would imagine the model could easily identify that. It knows all about sunflowers. What happens if I pass in a rose? It may be able to identify a rose. What happens when I pass in a tulip? The system blows up and it's the end of the world as we know it. In this case, we've trained a model that's biased or skewed towards sunflowers. and essentially hates tulips. It will more than likely think everything is a sunflower. Another bias example, and this is from Amazon's recruiting tool that basically said women don't make great engineers, and it was because of the data set. So they trained the machine learning model on past applications, and mostly men applied to Amazon in the software engineer position. And so the model learned that, hey, men make great software engineers. So it's always important, and I've said this already, for the model to be trained with data that represents the environment that the model will be deployed in. In the pre-machine learning world, humans made hiring, advertising, lending, criminal sentencing, all of those decisions. And in the US, these decisions are regulated by federal laws, state laws, and local laws. And it looks for fairness, transparency, and equity across those decisions. It's against the law to discriminate because of someone's age, gender, marital status, ethnicity, whether or not they're pregnant or on maternity leave, their nationality, religion, belief, or sex. But now machines make or heavily influence a lot of these decisions. And in the US, IP laws, intellectual property laws, protect the inputs to algorithmic decision making because it's considered a trade secret. So companies in the US right now don't have to share this information. And so I say discrimination wasn't allowed before machine learning. It should not be overlooked because of machine learning. When the outcome of a decision is biased, bad things happen. We unfairly allocate opportunities, resources, and information. We infringe on civil liberties. Can even pose a detriment to the safety of individuals. For facial recognition, if someone is misidentified, that could be a detriment. We fail to provide the same quality of services across the board. We can negatively impact a person's well-being, such as by being derogatory or offensive. Mental health is a big topic, at least in the United States. Everyone is focused on mental well-being. When people are discriminated against, it negatively impacts their mental health. And we've seen this happen at Google, where some of the systems they were developing in the US, their employees did not agree with and staged a walkout. So at the end of the day, when an organization builds a system that's biased, it puts its reputation, future opportunities, and consumer trust on the line. So when we look at the machine learning lifecycle, bias shows up all over the place, not just in the data. It shows up in your people, and we'll talk about that, your strategy, of course your data, the algorithm, the model, and the actions you take based on what the model says. So bias shows up in your people. People actually build the machine learning systems, and people have certain perspectives about life, right and wrong, and what's fair. So when you're looking at developing a machine learning system, take a look at your people. Is the team diverse enough to represent minority viewpoints? And is the person biased? And could that bias lead to transfer to the system? Take a look at your strategy. In the strategy phase, this is where you're exploring your current business process. You're trying to identify where machine learning adds value, and you're working to define the inputs and outputs to your system. Questions at this stage that you can ask: How could your system negatively impact someone? Could this system, for example, deem a repeat offender as a low risk? What prediction error rate can you tolerate? No machine learning system, at least none of the ones I've developed, have a 100% accuracy. So you need to understand what you're willing to accept. Is 75% good enough? 85%? 90%? And then from an explainability perspective, if someone calls in and you turn them down for a loan, how do you explain that no answer? This is the one everyone's familiar with, where bias shows up in your data. During this phase, there's a training phase, a preparation phase, where you're formatting your data and you're getting it ready for the machine learning lifecycle. At that stage is the best time to understand if there's bias. So you're analyzing and understanding, and if you're not a subject matter expert on that data, you need to be, or you need to work with someone who is. So risk and ethics questions that you can ask at this stage: will protected attributes like gender, age, and ethnic background influence the output of the model? Are seemingly harmless features like salary hiding protected attributes? So we often see that there's a strong correlation between income and race. So just naively doing income filtering, you may end up discriminating on someone's race. And then how will you enable end users to control the use of the data about them? We'll look at the GDPR and some of the requirements around data ownership later. So bias can show up in your algorithm. During the algorithm selection phase, you experiment with many different learning algorithms with your data set. I taught a 2-day machine learning workshop on Monday and Tuesday, and we tried many different learning algorithms. And we found out of the gate, with really no hyperparameter tuning, that XGBoost performed better on our data set. And then you'll also need to test performance using evaluation metrics to see how your model is performing. And you need to have that test data. So in our machine learning workshop, we reserved 20% of our data to do the validation, to test our model. So risk and ethics questions that you'll ask: which metric will you use to evaluate the performance of your model? And does your use case require a more interpretable algorithm, or one that allows you to experiment and adjust hyperparameters? And then bias shows up in your model. At this stage, this is where you're integrating your model output into your business processes, and you're identifying model retraining frequency, you're monitoring your system, and you're measuring and you're reporting the results. So questions that you should ask at this stage: do you have a plan to monitor the poor performance on individuals and set up your model for retraining? Do you have a plan to store the model output or the predictions in case a person asks more questions? And can a bad actor infer information about individuals from your system? Lastly, bias shows up in your action. So now that you have this prediction, what do you do? In this phase, you interpret the results and the outputs from the machine learning system, and you'll take the action. In your process, does a human review the output or the prediction from the machine learning system for fairness? Is it reviewed? How does that human provide feedback to you on the output? And how does the human understand and explain the output to someone else? So when we talk about ways to mitigate bias, you have options. Make sure that you ensure your data set represents the environment the model will be used in, and I've said that several times. That's one thing I want you all to remember. Determine if there are disallowed biases. We mentioned before the strong correlation between income and race. And in the United States, you can discriminate on income, but you cannot discriminate on race. Explore the correlations between your features. Are they highly related? We said that income is highly correlated to race, and you have to work hard to untangle that correlation. And lastly, determine the impact and decide if you're going to allow it. I'm sure many of you have heard about explainable AI, and it's an important part of ethical AI, and there are several components. And it just really boils down to being able to explain why your model made a particular recommendation. So you need to have explainable data. What data did you use to train and why? You need to have explainable predictions. What features and weights were used for that particular prediction? And explainable algorithms. Let's say if the model returns 75% confidence that a person will pay back a loan, is that enough? So there are several places where you can incorporate checks and balances and fairness. So you typically start up here with problem formation. And a question you can ask, is machine learning even an ethical solution to the problem? Machine learning is not always the answer when you're trying to solve a solution. Look at your data set construction. Does the data need to be modified or balanced to mitigate bias? In your algorithm selection, can hyperparameters be tuned for accuracy and fairness? In the testing process, has the model been evaluated using relevant fairness metrics? In deployment, is the model deployed on a population that it was not tested or trained for? And lastly, does the model allow for feedback loops during the retraining process? So a lot of this, incorporating this, is still very manual. It would be nice if there were an automated way to do this. Well, luckily, if you use AWS, there is. And I know AWS is not that popular on this side of the world, but back in the United States it's very popular. And we have a tool called SageMaker Clarify. It's a component of Amazon SageMaker, which is AWS's machine learning as a service solution. And it's a tool that integrates with SageMaker, and it allows you to test your data and your model for bias and fairness. It also provides explainability, helping you explain why your model made a particular recommendation. And it produces bias and explainability PDF reports. So when we go back to this screen and we're looking at incorporating Clarify in that machine learning process, there are 3 places where it integrates. First, you can use Clarify during data set construction. There's a tool called Data Wrangler, and we looked at this tool during my 2-day workshop. It helps you identify bias in your data before you train without having to write any code to do that. You can also integrate Clarify during the training and testing phase. You can create a processing job for detecting bias and explaining model predictions. And then on the back end, you can use Clarify to monitor your model while it's in production for drift. This tool was released in 2020, and I remember at that time, I was watching AWS reInvent, which is AWS's big yearly conference. I was virtual because of the COVID pandemic. And when they were on stage talking about all of the new releases, I literally jumped out of my seat, clapping and cheering when they announced Clarify. And I've really found the tool to be helpful. Now, there are 4 main areas when we think about bias and understanding predictions that Clarify can help with. First, it's the pre-training bias. So you can detect bias during your data preparation. It checks for class imbalances. You can use it post-training. You check your trained model for bias. You can use it for explaining your model behavior and monitoring. So today we're going to look at number 1, the pre-training bias and how you produce reports to help you understand your bias. If you ever want to explore AWS, I encourage you to explore it and reach out to me. I have a few free credits that I can give you if you want to explore Clarify and Amazon SageMaker. So pre-training bias in the public safety engine. So let's say we're generating a model that we're going to use to predict crime in the United States. In the UK. And it basically predicts if a stop is going to lead to an arrest. So there's stop and search data that the UK makes available from this link. And here's a quick look at that data. In the data, there's this outcome. Did the stop lead to an arrest? Yes or no? There's a date timestamp, which is great if you break that apart to find out the month, day of the week, the time for a machine to find patterns. There's the location, latitude and longitude, gender, age range, and ethnicity. So just from looking at this data set, there are 3 protected fields: gender, age, and ethnicity. And we want to be very mindful that bias does not present itself anywhere in those features. With SageMaker Clarify, it actually produces a report that contains 8 pre-training metrics after it reviews your data. Today, we're going to look at 2 of my favorite metrics: the class imbalance, CI, and the difference in proportions of labels, the DPL. So with class imbalance, it basically measures if features have equal representation. And for DPL, it measures the distribution of the positive outcomes. So the arrest. Will the stop lead to an arrest? Yes. And with pre-training, it's all about helping you understand how your data is distributed. So let's have a quick demo of SageMaker Clarify. And I have this Jupyter notebook. I've already pre-processed the data, formatted it for the machine learning process. So we're going to skip down to the Clarify portion, specifically looking for the pre-training bias report. And all of this code I can share with you after. So the first step is to create a SageMaker processing job to detect the pre-training bias. And there are 2 important configurations that we need to set up. The first is the data config, and it's just a simple configuration telling Clarify where the data to analyze can be found, where you want it to put the final report storage, what we are predicting, the outcome, and the type of data set being used. Next, we have the bias config, and that's all about the bias detection settings, where you define the favorable outcomes in a label value threshold field, and you define the sensitive columns that you want to monitor for bias. Next, we will run the processing job using the run pre-training bias function, and you pass in the data config and the bias config. Now, this processing will take several minutes, many minutes, especially depending on the size of your data. You have to have a lot of patience. You can leave your machine running, go get coffee, come back and check, go for a walk, and come back and check, and then the job is finished and your report is saved. So let's take a look at the output of the clarified job. So it's a really pretty PDF report. When you open it and you scroll down, the first thing you'll see is the data distribution of the outcome, so that predicted value, whether or not a stop will lead to an arrest. If you continue to scroll down, you'll see the 8 metrics that I mentioned to you. The 2 most important ones that we're going to look at, one is the class imbalance. So if we have equal representation across the data set, here a perfectly balanced class will give you a 0. So the value is 0.557, which means the balance isn't that great. So now I have this decision: how do I go back and correct my data before training? And then for DPL, the differences in proportions of labels, again, this measures the distribution of the positive outcome. Then the value there is 0.018. And the farther this value is from 0, the more bias exists in the data. So it's a very useful report with several metrics that you can explore to help you make decisions and understand bias in your data. Now, as we wrap up, you may be thinking to yourself, well, Kesha, ethical machine learning, it's nice. I can see why it's important, but I'm just a developer. I just code whatever I'm told to code. Well, as a developer, you could be putting your company in the hot seat, especially in the US, if the company breaks a law. So when we look at the GDPR on this side of the world, it requires you to tell individuals what information you hold about them and how you're using that data. And so this means if you're going to use an AI system, you need to tell that person that it's being used. So the GDPR calls out data ownership. So organizations need to get permission from users to capture their data for a specific use case. It also calls out the right to forget. The individual has the right to demand that you erase all of their data. The right to explain. That means that companies must notify users about how their data is processed. And AI and innovation. And it says AI cannot be the sole decision maker in choices that have legal or significant impacts on users. In the US, recently, as of October of last year, we introduced what we call an AI Bill of Rights. And it serves as a guide for the protection of people from AI. It requires that we build safe and effective systems and that people in the US be protected from AI. It has algorithmic discrimination protections. People should not face discrimination by algorithms. Data privacy. You should be protected from abusive data practices. Notice and explanation that's similar to the GDPR. You should know that an automated system is being used and understand how it contributes to outcomes about you. And then lastly, human alternatives and fallback. That we should be able to opt out of a machine learning system making a decision and opt for a human to make that decision instead. So when we think about our duty as engineers and developers, we all have a duty. It is no longer acceptable to just blindly implement a system, especially those that use AI and machine learning, just because your boss told you to do it. When you implement those systems, look at it from a moral and ethical standpoint and try to incorporate bias detection and mitigation and make the world a better place. Thank you. Okay, we have time for questions. If anyone has any questions. Yes.
So, the way I understood, you take a perceptive feature such as like ethnicity or age, and then you weigh that against the design outcome that's not interested. And that impact report shows you how biased it is. How do you manage if you have like 10 protected inputs? Obviously, you can't balance all of them to be fair. So, would you just iteratively try and get them all as low as possible?
So you're saying for the specific metrics, if for example, the class imbalance metric, if it's telling you one feature is imbalanced, then you can make it an iterative process where you go back and try to balance your data. And there are several techniques that you can use. Maybe you need to either get more data or impute data, add more data, but then you'll run it back through that, you'll keep tweaking it and running it back through that process to see the updated metrics and trying to get it to a point where it's not biased. Yeah. Any other questions? Hi, friend. How are you? She was in my workshop. Yes.
When it comes to data, I mean, in AI and being ethical, I mean, are we being fair to AI? Because we have not been able to solve ethical and bias for humans. So why we think that we'll somehow achieve this sort of perfect AI system?
It's never going to be perfect. Yeah, no system is ever going to be perfect with machine learning. Like you said, there's bias in every stage. People are biased. Historically, data could be biased because of, so for example, in the United States, there are, in Washington, D.C., there are police officers that actually travel with a laptop running a machine learning model, telling them where they need to patrol. But the data is historic data where they've historically patrolled in Black neighborhoods. And so it just sort of continues that cycle. But we can't, there are things that we could do to at least identify the bias and try to mitigate it before we put those systems in production. But it's never going to be perfect. It's not possible. Great question. Yes.
So I'm thinking about like how much tweaking should we do as engineers versus how much tweaking should be done by like domain experts. Because I'm probably gonna fail to like provide a good example, but I'm guessing there's some like inherently biased data sets because of whatever. Like
Right.
how do we stop ourselves from messing up the data by trying to like remove the bias when the bias is actually inherent and needed to actually make it?
Right. So it sounds like your question is related to sometimes bias is a good thing and it's needed. Yeah, and I would agree with that. It's really all about your use case. So, for example, at the beginning, we had the example where machine learning could actually detect breast cancer that was undetectable by a doctor. So, in that case, bias is good because it could actually save someone's life. And so, it really just depends on your use case. You have to take each use case into account and determine what's fair, what's right, what's bias. Is it good bias or bad bias? Great question. Any other questions? Okay. Well, thank you all for joining. If I can ever convince you to come over to the AWS side, let me know. I have a few free credits to give away so you can experiment with machine learning. Thank you.